Yo, what's up? Can anybody hear me? Is the sound quality good? Okay, so as requested, as voted, I put up a post about what topic you guys want me to do from Pure Math 1. And it was you guys basically voted for trigonometry, so that's what we are going to be doing today, Pure 1 trigonometry. And yeah, let's start, I guess. So this right here, this table that you guys can see, this is called a trig table. I'm just going to go into full screen mode here. I think that's okay. I'm just going to check if this is properly visible on the stream. Give me a second. Yeah, okay, I think that this is properly visible. Okay, so what is a trig table? Well, so if you look at the first row, we sort of have all of these things. I'm just gonna get a pen over here. So we have all of these guys, these guys. So these are basically the angles. As you can see, they're right in. Oops, what did I do? I'm supposed to do that. I'm gonna go back up. So all of these values, these are the values for this thing. This is called this is the angle theta. And so you have the main possible angles that you are going to be seeing in your trigonometry pure 1 is going to be all of these angles. So you have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and then 90 degrees. And then of course there are the radian versions as well, which is 0 radians, pi by 6 radians, pi by 4 radians. Now what is a radian? Well, a radian is a different way of measuring an angle. It's just like you have degrees Celsius and degree Fahrenheit for temperature, you have radian and degrees for measuring an angle. Now, how do you go from degrees to radians and how do you go from radians to degrees? Well, there's this thing called pi by 180, and then there's this thing called 180 by pi. And so the way you do it is basically if you want to go from radians to degrees, then what you do is, so if you have, let's say, 60 degrees, and you're trying to go into radians, so you basically whatever you're trying to go into, that thing has to be in the numerator. So if I'm trying to go from degrees to radians, then pi has to be in the numerator. Whereas let's say if I have um, pi by 3, and I'm trying to take this into the degree mode, then what I'll do is I'll multiply this with 180 over pi. So if you're trying to get degrees, 180 has to be in the numerator. If you're trying to get radians, pi has to be in the numerator. That's how you go from degrees to radians and radians to degrees. Now, under these thetas, under these possible angles, you have sine theta, cosine theta, and tan theta. And what these do is essentially, see, if you have all of these angles thetas, you put these in the sine function, you put these in the cosine function, you put these in the tan function. What's going to happen is you're basically going to get some value out of it. So that's what the values are, what we're going to write in these boxes. So what is sine theta when the angle is 0 degrees or 0 radians? So that, and you have to learn this. You can use a calculator, but you have to learn this. Like you need to know these values off the top of your head. So I'll just teach you guys how to construct this table, and then when you go to your exam, you can just construct this table in the beginning, and then you can just sort of come back to this table whenever you want to look up a value. So sine 0, so basically you put this angle in here, then you're going to put that angle in here, and so all of those angles are going to have specific values. So sine 0 is 0. And then sine 30 or sine pi by 6 is 1 by 2. And then sine 45 is going to be 1 by under root 2. And then sine 60 is going to be under root 3 by 2. And then sine of 90 is going to be 1. So these are the values you need to know. You need to remember what value you get for what angle in the case of sine. And then cosine is basically just the flip of this. So if you're going from left to right, now you just go from right to left. So what I mean by that is basically for the sine you're going from here to here. From the cosine, you're just going to start going in reverse, and I'll show you guys how that works. So basically, cosine theta, you put 1 over here, and then you put, for cosine 30, you put under root 3 by 2, then you put 1 by under root 2, then you put 1 by 2, and then you put 0. So you can see how sine theta and cosine theta are going in reverse. Now tan theta is a little different than the first two. So the key values I can tell you over here, the easiest values are, so tan 0 is going to be 0. That's straight up as simple as that. Tan 90 is going to be infinity or undefined. So you may even see or undefined. So infinity, undefined, whatever you want to call it. And then tan 45 is 1. So these are the main values that you need to know. And what about 30 and 60? So the way you write that is, see, over here you have this 30, right? And so it's the 30 involves a 3, so then tan theta is also going to involve a 3. What it involves is 1 over under root 3. That's one way of learning it. And then tan 60 is just the reciprocal of this, so it would just be under root 3. That is the trig table, and you need to know these values. And one easy way of doing this is just draw this table, learn how to draw this table, and whenever you want to pick up a value, just go and look at the value from this table. That's a really easy way of doing it. Now we basically have graphs. Once you've sort of learned these values, you basically have these graphs. So you can basically plot out the graph of sine theta, you can plot out the graph of cosine theta, you can plot out the graph of tan theta. And what we commonly do is see your angles go in a circle. They have a cycle. So basically, if I draw a circle over here, how many degrees is this circle? So let's say if I start over here and I go all the way around this circle, come back over here to this point, how many degrees have I covered? So I've covered 360 degrees. That's how big a circle is. That's how big a cycle is. And in radians, 360 degrees corresponds to 2 pi radians. Okay, so a cycle or a circle is 360 degrees. And so we basically split this into 4 quarters. So we've split it into 4 quarters. So this is where we're at 0, then this is 90 degrees, and this is 180 degrees, and this is 270 degrees, and then this back is going to be 360 degrees. Or 0 degrees, it's the same thing. Now we split it into 4 quarters, and then we use these quarters to sort of, deal with the other values of sine, cosine, and tan, etc., etc. Okay, coming to these graphs, how do we sort of use this table to sort of plot out the graphs for sine theta, cosine theta, and tan theta? And what do their graphs look like? So, and you do also need to remember the shapes of these graphs. So when I'm done drawing out the shapes of these graphs, you do need to remember what they look like. So what I want you guys to notice over here is that, see, we just talked about a cycle, and we were like, we're going to split it into 4 quarters, where this is 0, this is going to be 90, this is going to be 180, this is going to be 270, and then that is going to be 360. And see, that's actually what I split it into. So this is 0, then you have 90, then 180, then 270, then 360. So we basically split the graph into those 4 quarters. And on the x-axis, we represent the theta, the angle, and on the y-axis, we represent whatever value we get when we put that angle theta in the sine function. Okay, so you put that angle in the sine function, you're going to get some value. We represent that value on the y-axis. So what we've done over here is we've split the cycle into 4 different quarters, and using those quarters, we're going to plot out y equals sine theta. So let's start off with the first point, 0. What is the value of y when theta is equal to 0? Then again, you have this sort of this table, right? You can sort of go and check out the value of sine theta when your angle is 0. And sine theta is basically 0 at that point. So you put the first dot right over here. Then you go to 90 degrees and you check out what the value of y is at that point. So you can clearly see it's 1. You come back over here and you put a 1 over here. And then you check out what the value is at 180 degrees. Now this is a little bit tricky. You're like, well, if I go back into the table, I'm not seeing any 180 degrees. So how am I supposed to do this? Well, a cool thing is that if you have this sort of this cycle, what happens is that the values that are corresponding, so let's say 0 and 180 degrees, they correspond to each other. And then 90 and 270, they correspond to each other. So what I mean by that is, let's say you get at sine 0, the answer you get is 0. So then at sine 180, you're also going to get 0. Sine 80, you're also going to get 0. Sine 180, you're also going to get 0. Now, ideally, whatever number you have over here, you get the negative of that over here. But see, thing is, 0 doesn't have a sign, so 0 would just be 0. But if I talk about this 90 degrees, what is sine 90? Let's check it out. Sine 90 is equal to 1. So this is equal to 1. Now, sine 270 is also going to be 1, but it's going to have a different sign, right? It's going to have the negative sign. And now the same thing would have applied over here if you have a positive number over here, you're going to have that same number, but the negative of it on the other side. The problem is 0 doesn't have a sign. So 0 just stays as 0. So you don't know what sine 180 is, but you know that sine 180 corresponds to 0. So that means that sine 180 is also going to be 0. You put a dot over here. And then the next point is 270. So what is sine 270? If you go into your table, you do not have a value for it. But what you do know is that 270 corresponds to 90. It's on the opposite side of 90. So it's going to have the same number, but the opposite sign. So if sine 90 is 1, sine 270 is going to be 1 as well. But it's going to have a negative sign. It's going to be negative 1. That's going to be somewhere around here. And then what is sine 360? So remember, when you complete all of this cycle, this first starting point is also 360 degrees. So 0 is going to be 0 and 360 is also going to be 0. They're both at the same position, right? So this is going to be 0. Okay, now once you've done this, you need to know how to draw out this curve, because it can be something like this, like this, like this, like such. It can also be something like this, and then something like this. So what the shape is going to be, you do have to memorize that shape. And that shape basically is going to look something like this. So you have a curve going up like this. You have a curve coming down like this, kind of like a rainbow. And then you have a flipped rainbow. So it would be something like this and like this. This is what a sine graph looks like. Now this is super important. This is what one cycle of a sine looks like. So one cycle consists of 360 degrees. So we went over those 360 degrees and we figured out that this is what one cycle of a sine wave looks like. This is really important. You do need to have this rough idea of what a sine looks like in your head. And we go over here to the graph of cosine theta. And this time, instead of having the angle been given in degrees, it's given to us in radians. And we need to know how to deal with the radians as well, because you're going to be dealing with both radians and degrees. We're going to plot out the graph of cosine theta in the same way we plotted out the graph of sine theta. So what is cosine 0? Let's check it out. Cosine 0 is 1. So it's going to be right over here. You put a point right over here. And then what's cosine pi by 2, or cosine 90 degrees? So that's equal to 0, right? cosine 90 is equal to 0. So we put a point right over here. And then what's cosine pi? Now pi is 180 degrees. So how do we, again, remember, you plot out your circle and you realize that if 0 is over here, then 180 is its corresponding part. And at cosine 0, your value is 1. So when you split it to the other side, when you send it to the other side, it's still going to be 1, but it's just going to have a negative sign next to it. You put a dot right over here. And then what's cosine 3 pi by 2, which essentially means 270. So cosine 3 pi by 2 or 3 pi by 2 means 270 degrees. You can convert it using the method I just told you guys at the start of this video, and you will find out that it's equal to 270 degrees. So if you have 90 degrees over here and you have 270 degrees over here, then what's cosine 90? It's basically equal to 0. So then the opposite side will just be 0 as well. And zeros have no signs, so it doesn't matter. Signs don't matter over here. They put a dot at this point. And then what's going to be cosine 2 pi? So 2 pi is 360. 360 degrees is at the same position as 0, so it's going to be 1. Going to be 1 over here. And again, this time you do need to memorize how the shape of the curve is going to look like. Because it can be something like this, or it could be something like this. So it's really important that you know how the shapes work. So you draw a curve sort of like this, and then you draw a rainbow for the bottom part, sort of like this. And then you draw a curve like this. Okay? So this is what one cycle of a cosine graph looks like. It looks something like this. Okay, kind of like a weird U shape or a weird V shape. So this is the rough drawing of a cosine graph. Now, how do you draw a tan graph? So tans are a bit tricky. They're not as simple as sines and cosines, but we're going to learn how to draw a tan graph. Now, again, what is the y value at tan 0? So basically, when tan is 0, so when tan of 0 degrees, you basically get an answer of 0. So you put your point right over here at this point. And then what is tan at 90 degrees? So if you check it out, tan at 90 degrees is actually infinity. Now, how do you deal with infinities? Infinities are not common numbers. So the way you deal with them is you basically draw a line, dotted line, sort of like this at 90 degrees. And then you put a dash over here, and you put a dash over here. That's what you do for infinity. And then what you basically do is you draw a dotted line wherever, at whatever angle you get infinity, you draw a dotted line and put the dashes like this. So the dashes aren't like this. Don't put the dashes like this. This is going to be wrong. Put the dashes in the pattern I show you in. Okay, and then what do we do for 180 degrees? So what is tan 180 degrees? So what is 180? 180 is basically, if we split it into the four quarters again, this is 0, this is 180 degrees. So if this right over here, if tan 0 is 0, then tan 180 is going to be 0 as well, and there are no signs for 0, so we don't have to worry about signs. So we put a dot right over here. And then what about 270? So 270 is right opposite to 90 degrees. So that means we're going to have infinity over here as well. So if 90 was infinity, we're going to have infinity over here as well. So again, the way you draw infinity is you basically draw a dashed line going through whatever angle you have infinity on. And you're going to put one dash over here, and you're going to put another dash over here. And finally, what about 360? So 360 lies on this point over here, and it's going to be the same as whatever 0 was. So at tan 0, the answer is 0. So at tan 360, the answer is going to be 0 as well. You put a point over here. Now, how do you join these points? Are these points joining like this, like this, like this? This is important. How you join the points is really important as well. So the way the tan graph joins is you first draw a curve like this all the way up to that dash. And all the way up to that dash, what does that even mean? That means it's going all the way to infinity. It doesn't have a fixed value. Going all the way to infinity like crazy. And then you basically start from this lower dash and you bring it up all the way to this 0. And then you basically flip the direction of the curve and you send it back up. Sort of something like this. And you do the same thing once more. So you bring this curve up sort of like this. So that's what a rough drawing of a tan graph looks like over 360 degrees. So this is how you draw your graphs of sine theta, cosine theta, and tan theta for 360 degrees or 2 pi. Now moving on to the next part, there's something you can do to basically alter the shape of these graphs. And you basically, this is the rough, you can say sort of a blueprint of what's going on. So you have y equals, and see these are for sine functions, cosine function, tan function. So it doesn't matter what you have. The p, q, and r represent something really useful. And I'll tell you guys what they represent. So let's say I take a graph of sine. So a sine looks something like this. So this is y equals sine theta. And the graph looks something like this. Now you do have to remember the rough shape of this. Okay? Where this is going to be 360 degrees, this is going to be 270 degrees, this is going to be 180 degrees, and then this is going to be 90 degrees. Right, I'm just splitting it into the 4 quadrants we talked about. And we saw that this was going all the way up to 1, this was 0 over here, and then at the bottom it was going all the way to -1. So this is what the rough sketch of a sine graph looks like. Now, what happens when you start adding these constants, these p's, these q's, these r's? What did they even mean? So r is basically for the baseline, and baseline is a starting point where your graph starts at. So if you look at the baseline over here, it's this line. A baseline is basically wherever your graph starts from. Now this line in pink, this is the baseline. This is where my sine theta starts off from. So you have this thing going up. It started from this point, it was going up all the way, and now it's going down. So what would be the value of r in this case? Well, the r is going to be 0 because the baseline is this 0 line. Okay, now what if I do something different? So what if I had this point over here? Let's say I had this part over here. I draw a line on 1, and I drew my sine function over here, something like this. So now my baseline would basically be equal to 1. First of all, when I was dealing with the first example, my baseline was 0. Now I basically started at 1. I drew my sine curve at 1. So now my baseline, my value of r is going to be 1. So r represents the baseline. This r, this r, this r, this represents the baseline. It's a little different for tan functions, so we're just going to ignore tan functions for now. It's a little different for tan functions. Tan functions are not that simple, so a little different. But for cosine and sine functions, talking strictly about cosine and sine functions, the r represents the baseline. So, and what is a baseline? A baseline is where you start your curve at. That's what a baseline is. What about q? What is q? So q is how is I've even written it over here. So q is how the number of waves you complete in one cycle. So what does that mean? So let's say one sine wave looks something like this. Now over here, if you look at this sine theta, can you guess the value of q? So q is basically equal to 1 over here. And the reason for that is because, well, if you put a 1 over here, then 1 theta is just going to be equal to theta. So what that means is it means the number of waves you're completing in one cycle. And one cycle is of 360 degrees. So you're completing one sine wave in 360 degrees. This is what one sine wave looks like. Let's say I change the number over here from 1 to 2. What's gonna be the curve? What's gonna be this graph over here? What's the graph gonna look like right now? So it's basically going to look like two sine waves. So this would be one sine wave, and then this would be another sine wave. And you would be completing two sine waves in one cycle, or two sine waves in 360 degrees. So it would basically look something like this, That's one sine wave, and then that's going to be another sine wave. So you're going to be completing two sine waves in 360 degrees. And the way I guess that is basically if you're going to be completing two sine waves in 360 degrees, then that means you're going to be completing one sine wave in the half of 360 degrees, and the half of 360 degrees is going to be 180 degrees. So basically one sine wave gets completed in 180 degrees, and then the next sine wave gets completed in the remaining angles. So you have a graph that looks like this. This is what happens when I change q to 2. Now let's say I change q to 1/2. So I change q to a half. Now this means you're going to be completing half a wave in 360 degrees. So a sine wave looks something like this, right? Now what does a half sine wave look like? A half sine wave looks something like this. So I'm going to be completing half a wave in 360 degrees now. So it's going to look something like this. That's half a wave that's being completed in 360 degrees. So Q changes the number of waves that you complete in one cycle. Q tells you how much waves you're going to have in one cycle, or how many waves you're going to have in 360 degrees or in 2 pi radians. That's what Q means. So R means baseline. Baseline is where you start your curve at. Q means the number of waves you complete in one cycle. What does P mean? So P is for amplitude. What is amplitude? Amplitude is basically the number of units you go up from the baseline and the number of units you go down from the baseline. So what do I mean by that? So in this example, this line 0 is our baseline. Now amplitude is how much do I go up from this baseline, and I go up by 1 unit. How much do I go down? I go down by 1 unit. So the amplitude P is going to be equal to 1. What if I change P to, let's say, 2? So right now P is 1 over here. What happens when I change P to 2? Say I change this to 2. Now my amplitude is going to be 2, and I'm going to have -2 over here. This is going to change. This is going to go all the way up till -2, all the way up till +2, and then all the way up till -2. That's what amplitude does. Amplitude is basically how much you go up from the baseline, the maximum amount that you go up from the baseline, and the maximum amount that you go down from the baseline. That's what amplitude means. So now we know what P, Q, and R mean. Let's try out some questions to cement this idea. And we have this question over here, it's taken from the past papers. And we can see that we have a graph, which is y equals a cosine bx plus c. And see what they've done is we had P, Q, and R. They've replaced them with A, B, and C. So that doesn't matter, right? The symbols, they don't matter. We know what they're talking about. Okay. We need to find the values of the positive integers a, b, and c. So we know what they represent. We know what a represents, we know what b represents, we know what c represents. So c represents the baseline. B represents the number of waves, so the number of waves in one cycle, or 360 degrees, which is one cycle is 360 degrees, or it's 2 pi radians. And then A represents the amplitude. Amplitude is how many blocks do we go up from the baseline and how many blocks do we go down from the baseline. Okay, so we have a cosine function over here. Now a cosine function, what does a rough cosine function looks like? It looks something like this. And if I draw out the axes over here, this is what a rough cosine function looks like. Okay, first thing I can see right off the bat is that there are two cosine waves being completed in 2 pi. So 2 pi, this is one cycle. I can see two waves being completed in one cycle. So the first wave starts from here and ends over here, right? That's what one wave looks like. And the next wave starts over here and ends over here. So those are two waves that are being completed in one cycle. So what is B going to be? B is going to be 2. B is going to be 2. What about C? So C is the baseline. Now, how do we figure out the baseline? This is a tricky part. How do we figure out the baseline? Now, see, the way you figure out a baseline is if this is the baseline, you have equal number going up and equal number going down. So if, let's say this, if you say this is my baseline, this is not your baseline because you're going up less than you're going down. They both have to be equal in number. So how do we choose a baseline? Okay, so now each block over here, each block represents two units. If you go from 2 to 4, that means you went 2 units. So this comes from a bit of trial and error, but let's say I say this is my baseline. So I check how many blocks do I go up, or how many numbers, how many units do I go up. So from 4 to 8, I go up by 4 units. What about from 4 to -2? How many units am I going down? So this is 2 units down. This is 2 units down. This is 2 units down. So I went down by 1, 2, 3, 4, 5, 6. I went down by 6 units. So this cannot be my baseline because those numbers are not equal. So how about I change my baseline and I put my baseline right in the middle of 2 and 4. So in the middle of 2 and 4 you have 3. Okay, now how much do I go down? So this is going to be 1 from, if you want to go from 3 to 2, you're going down 1 unit. And then from 2 to 0, you're going down 2 units. And then you're going down 2 units again. So you go down basically by 5 units. And then how much do you go up? This is from 3 to 4, it's 1 unit. Then from 4 to 6, it's 2 units. Then from 6 to 8, it's 2 units. You go up by 5 units. So this seems like a good baseline. So C has to be 3. C has to be 3. Now what about the amplitude? Well, we've already figured out the amplitude as well. It's going to be 5. Going to be, A is going to be 5. The amplitude is going to be 5. That's how much you go up, that's how much you go down. So then this graph is basically going to be y equals 5 cosine bx, so that's going to be 2x plus c is going to be 3. And I want to point out to something. You can see how instead of giving you theta, they gave you x. But that doesn't matter. Whether they give you x or whether they give you theta, it's the same thing. So that doesn't matter. Don't freak out when you look at that. So this is what the graph or the curve is going to look like. Okay, going down to the next part, we have a diagram that looks like a sine, and it is a sine. They even show us that it's a sine. So what we're supposed to do is we're supposed to state the value of P, state the value of Q, state the value of R. Okay, so what is R? R is a baseline, and it's really obvious. For a sine graph, it's really obvious. This obviously clearly looks like the baseline. Really obvious. You can just look at it. You can see, oh, this is where the sine is starting from. That has to be the baseline. So the baseline R is going to be equal to -2. What about Q? So Q is the number of waves that you complete in one cycle. One cycle is basically 2 pi or 360 degrees. So this is 2 pi. How much waves are you completing in 2 pi? So you're completing this much wave in 2 pi. Okay, how much is this? If you draw a sine curve like this, how much is this? Is this the full wave, or is this the half wave? And it is the half wave. That means you complete half a wave in one cycle. You complete half a wave in 2 pi. So the Q is basically going to be 1/2 or 0.5, which means half a wave. You complete half a wave in 2 pi. And then what is going to be P? What is going to be the amplitude? How much do you go up from the baseline? How much do you go down from the baseline? So you're going up by, let me just erase this. This is the baseline. And we go up by 1. From -2 to -1, you're going up by 1. And from -1 to 0, you're going up by 1. And then you're going up by 1 again. So you go 3 units up. And then you go from -2 to -3, -3 to -4, and -4 to -5. You're going down by 3 units. So P is going to be equal to 3. So your amplitude is 3. Now moving on to the next part, and what we have to do is we have a curve that has the equation y equals 2 plus 3 sine 1 by 2x for x is greater than or equal to 0 and smaller than or equal to 4 pi. And I'll tell you guys what this thing means in a second. And we need to find the greatest and least values of y, and we need to sketch the curve. So we have this equation over here, and we have to sketch out this equation. And we're given this sort of these possible values for x. So what is x? So instead of theta in this question, they've given us x, and that doesn't matter. That basically means that x is our theta. So x is our angle, or x is our theta. And they're saying that the theta must be between 0 to 4 pi. So that means 2 cycles. We have to draw this for 2 cycles. From 0 to 2 pi, you're going to have 1 cycle. Then from 2 pi to 4 pi, you're going to have another cycle. So this is your first cycle. And then this will be your second cycle. So you're drawing 2 cycles. Okay, so how do we sketch this graph? First of all, we have this equation, y equals 2 plus 3 sine 1 by 2x. Let's rearrange this, because if you want to sort of draw this out, you need to know what these 3's, 2's, 1 by 2, what all of this represents. So we know what this thing means, p sine q theta plus r. We know what this thing means. So let's try and rearrange it and get this form. So we'll write this 2 over here, and now we basically have 3 sine 1 by 2x plus 2, and you can see that this is going to be in the form p sine qx plus r. And now it's going to click automatically. You're going to know what they're talking about. So basically, our baseline, this thing is equal to 2. So our baseline is going to be 2. So if I just plot out the values over, or actually I'll do that later. So the baseline is equal to 2. What about the number of cycles that we are completing? So we're completing half a cycle. We're completing half a cycle in 360 degrees. We don't need to write this in degrees because this question has been given to us in radians. We're completing 1 by 2 cycles we're completing 1 by 2 waves in 1 cycle, or in 2 pi. And then P is given to us as 3. So this means the amplitude, this means half a wave in 1 cycle, and then this means the baseline. Okay, so we need to state the greatest and least values of y, and we basically get the least and the greatest values. So if this is your sine, right, your sine curve looks something like this. Now the greatest possible value is going to be at this point, and the lowest possible value is going to be at this point. The way you find those values is basically, let's say this is your baseline. Then you just go up the amount of amplitude and you go down the amount of amplitude, and then you get your maximum and your minimum value. So the least and the greatest value, how do we find them? Well, the baseline is 2. So you go up by 3. So if you're at 2 over here, and you go up by 3, then you're going to get 5. Right? You're going to get 5 over here. Because you add 3 into 2, that's going to be 3, 4, 5. And then you subtract 3 from it, so you're going to get 2, 1, 0. Actually, I'm forgetting the what am I saying? I'm forgetting the arithmetic. So this is basically going to be -1. When you subtract 3 from 2, you basically get -1. So that's going to be your least possible value. So the greatest value is going to be 5, and then your least possible value is going to be -1. Okay, so what we need to do is we need to first draw our baseline. So this, our baseline is going to be at 2. This is our baseline. This is where we're going to start our curve at and our sine wave at. This is the point. And this is going to be pi. This is going to be 2 pi. So this is pi. This is 2 pi. This is 3 pi. And this is 4 pi. Okay. And then we're going to go up to a maximum value of 5. That's going to be 5. And we're going to go to a lowest possible value of -1. -1. Okay, now let's plot out our graph. So is it going to look like this? Is it going to look like this? How is it going to look like? That's what Q tells you. So Q tells you that you are going to be completing half a wave in one cycle. Half a wave in one cycle. What does a full sine wave look like? It looks like this. You're going to be completing half of this. This is half. You're going to be completing half of this in 2 pi. Okay, so from 0 to 2 pi, you're going to be completing that much. So that means that the rest of this, you're going to be completing in another 2 pi. So when you add another 2 pi into this 2 pi, you're going to get 4 pi. So your curve is going to look something like this over these 4 pi. Okay, so the way we draw it out now is we basically we get this up until 2 pi, right? And then we get the lower part. We get the lower part until 4 pi. This is how we draw it out. And you have to be careful. So see, my maximum value is touching that 5, and my minimum value is touching that -1. So you don't want to sort of do this, because then you would be going over that maximum value of 5. Okay, so this is how you can then use your knowledge that you learned over here to not only figure out what graph you have, but also to sketch whatever graph you have. Okay, so going on to the next part, what we need to know now is how do you solve trigonometric equations? And that's where graphs come in handy. That's where we're going to use these graphs to solve these trigonometric equations. So the first equation is sine theta is equal to 0.5. And we need to, and we were given this range, or we're given these possible values of the angle theta. So we're going to go from 0 degrees all the way to 360 degrees. Okay, so first of all, what does this even mean? What does this thing even mean? So what this thing means is that you can basically have sine theta equals 0.5. We've solved simultaneous equations, right? We all have, and let's say in simultaneous equation, you have a curve that's like this, x plus 1, and then you have a curve like this, x squared minus 2x. And what you do is you basically say y equals y, and you put x plus 1 equals x squared minus 2x. That's how you merge two equations when you're solving simultaneous equation. If you realize, that's what they've done over here. So if you reverse engineer this, you can sort of see that this could be one equation, y equals sine theta. This could be another equation, y equals 0.5. 0.5 is 1 by 2, whatever you want to call it. And then what they've done is they've put this y equal to y, and they've constructed this equation sine theta equals 0.5. So what does it mean to solve two equations simultaneously? What does it mean to solve a simultaneous equation? It means that they will have a common solution, or they will have an intersection point. If that's what you can recall from your coordinate geometry. So that's what they've done over here. They have two graphs, y equals sine theta, y equals 0.5, and they're trying to find a common solution. So I'm basically going to draw out this graph. So this is your theta, this is your y. Now, first of all, you can just go ahead and draw a rough sketch of your y equals sine theta, and we know what our y equals sine theta looks like. It looks something like this. Okay, where this may be 2 pi, and this may be 3 by 2. Wait, we're supposed to do this question in degrees. Remember, they've given you the values of theta in degrees, so we can just go ahead and do this in degrees. This is 360 degrees, and this is 270 degrees. This is 180 degrees, and then this is going to be 90 degrees. Okay, so this is what your sine graph looks like, and then this, the maximum value of a normal sine graph is 1, and then it's -1. If, of course, if the amplitude is 1, if we're talking about this graph, right? If it has 1 over here, that just means the amplitude is going to be 1. So we have this curve and we have this line. This is y equals 0.5. Now, what does a line of y equals 0.5 look like? Well, it means you're going to have 0.5 somewhere over here, and it's going to be a horizontal line. The horizontal line is going to look something like this. You can see these two graphs sort of intersect at 2 points. Now, that's what we're trying to find. We're trying to find the value of theta. We're trying to find this value of theta, and we're trying to find this value of theta. That's what it means to say sine theta is equal to 0.5. We're basically trying to find those two intersection points. So how do we sort of do that? Now you have to know that the sine graph, cosine graph, tan graphs, they're really similar in shape. They have symmetrical properties. So basically what that means is whatever you have over here, however much angle you're going to go over here, that's going to be the same amount of angle you're going to go over here. So that's why you can just look at it, and it makes some sense that, okay, if this part, if you have a mountain that's sort of like this, and you have 2 points over here and over here, and they're horizontal points. There's a line passing through them, so it's a horizontal line, and there are 2 horizontal points. And basically, however much you're going to travel over here is going to be the same amount that you're going to have to travel from over there, the other side. That's what's crazy about these graphs. That's how you can find out the values of theta. So basically, the way you do that is, the way you solve this out is, if you want to find the two values of theta, one thing you can do is you can make, in this equation, you can make theta the subject by sending this sign over there. So it's going to be sine inverse now. And this is going to be 0.5. And when you solve this out, you're going to realize, when you solve this out, sine inverse of 0.5, you're going to realize it gives you 30 degrees. And you're like, well, that's really nice. So, and can you guess, is this point going to be 30 degrees, or is this point going to be 30 degrees? And it makes sense, right? Because if this is 90, then that means 30 degrees has to be somewhere on this side. It has to be less than 90. So of course, that means that this point right over here is going to be 30 degrees. 30 degrees. But you were like, oh, my calculator only gave me one answer. It didn't give me another answer. I have 2 intersection points over here. So how do I find that other intersection point? That's where you use the symmetric properties. That's where you say, oh, if I have to go 30 over here, this was 0 degrees, right? So you move 30 degrees to the right side. Then that must mean that I must move 30 degrees to the left side from over here in this position. So and that makes sense, right? Again, because they're symmetrical. They're similar to each other. They have those symmetric properties. So if you move 30 degrees over here to the left side, then the way you can find that out is, well, you started off over here. This angle was 180 degrees. If you're trying to move to the left side, all you can do is you can say 180 degrees minus 30 degrees, and you are going to get 150 degrees. So that's going to be your other answer. It's going to be 30 degrees and 150 degrees. Those are going to be your two values of theta. And it makes sense, right? Because this is 90 to 180, and 150 lies between these two numbers. And over here, this 30 makes sense because there's this 0 and there's this 90, and 30 degrees lies between those two angles. So the two answers are 30 degrees and 150 degrees. Now the calculator is only going to tell you one answer, not going to tell you two answers. So you have to sort of use your brain and use these symmetric properties to figure out that other angle as well. Now we're going to move to the next part, and for the next part we have a cosine graph, and the question says we have to solve cosine theta is equal to 0.39, and the values that are allowed for the angle theta are from 0 degrees all the way to 360 degrees. So let's again do it in the same way. The first thing we do is we sort of draw out a rough sort of a rough graph of cosine theta. This is going to be y, this is going to be cosine, oh sorry, and this is going to be theta. So this is a graph of y equals cosine theta. And basically, what we're going to have is this is going to be 0. This is going to be 90 degrees. Again, those 4 quarters of a circle, right? You remember 0, 90, 180, 270, and then 360, those 4 quarters. So 90, 180, 270, 360. And then a cosine graph basically looks something like this. Sort of like this, okay? And this, the maximum point would be 1, then the minimum point would be -1. And then again, this is when y equals 1 cosine theta, right? The 1 is how much the amplitude is going to be. If this was instead 2, then your maximum and minimum values would obviously be 2 and -2. Okay, but right now we're dealing with a cosine graph. We're in a normal cosine graph, so the maximum value is going to be 1, the minimum value is going to be -1. Now we have cosine theta being equal to 0.39, and we can see that 0.39 is going to be, if we draw a line, it's going to be somewhere over here. This could be 0.39. I don't exactly know where it's going to be. This is all sort of a rough sketch. That's just how much information you need to solve out a question like this. Don't need much information. It's going to be all the way over here. Okay, so 0.39 is intersecting the cosine graph at 2 points, over here and over here. So we need to find out the value of theta at these 2 points. So it's one of them is going to be this value, one of them is going to be this value. Now again, you see you can sort of use some symmetry over here. If you have this thing and it's like this, and you see there's a line going through these 2 points, this point and this point. One thing you can do is you can see that however much angle this part is going to be, this part is going to be the same amount of angle. Okay, I hope that makes sense, because again they have these symmetrical properties and we can sort of use them to find out other values as well. So first of all, we can see this has 2 intersection points, so we're going to have 2 answers. So what we can do is we can find out the first answer just using this equation, cosine theta equals 0.39, and you send the cosine to the other side, it becomes cosine inverse of 0.39, and when you solve this out, you are going to get cosine inverse of 0.39. So it gives you, I'm going to round this off, this gives you 67.05 degrees. 67.05 degrees. Okay, so where is the angle going to be? Is this angle? Is this angle going to be this one going to be 67.05 degrees, or is this one going to be 67.05 degrees? And it makes sense it's going to be this one. Why? Because this is 90. So 67.05 can only be less than 90. It can't be more than 90. So the first angle, this guy is 67.05 degrees. Okay. So then if we know the first angle, how can we sort of find out that second angle? Now see, you need to know this this part, because you know that this part is equal to that part. So you found out the first angle, right? The first angle you found out that if you go the right this much, you're going to get an angle which is 67.05, and that's going to be one answer. So theta is equal to 67.05. That's one answer. But you can see there is another answer. You can see there is another intersection point. The way you find that is you look at this guy and you say, oh, this guy is going to be equal to that guy. And then the way you do this is you say, okay, well, how do I find this green part? How do I find this green part? And you can find that by saying 90 minus 67.05 going to give me that green part. So you subtract 90, subtract 67.05 from 90, and you get 22 22.95 degrees. Okay, so now you have, if this, that means this part is 22.95 degrees. Now, how do I know what this blue part is going to be? How do I know what this blue part is? Well, you know this part is 270, right? You just add, of 270, you just add 22.95 in there. You're going to get, so you are going to get 292.95 degrees. And 292.95 degrees. There you go. Those are going to be your two angles. Now we start off with the third question, and it says tan x minus 1 equals 0, and this time you're not allowed a full cycle. You're allowed from 0 to pi. Pi is 180 degrees, so you're just allowed to draw half a cycle. You're not allowed to draw a full cycle. Okay, so you have tan x minus 1 equals 0. So we don't know how to solve this. We don't know how to solve tan x minus 1 equals 0. But guess what we do know how to solve? If I send this thing over there to the other side, you make tan the subject, now you do know how to solve this. It basically means that tan x is equal to 1, so this will be one graph, this will be another graph, and you have to find their intersection points. So basically, I can draw out my tan graph over here. Y equals tan theta. This is my theta, this is my y-axis, and I'm only allowed values up until pi in this case. So I'm not going to use anything greater than pi. I mean, you can draw out the graph if you want to. You can draw it up to 2 pi if you want to, but you're just going to be wasting time. You don't have to do that. So we have 0, we have pi by 2, and we have pi. And see, I'm not drawing it in 360 degrees. I'm not drawing it in degrees this time. I'm not sketching out my graph in degrees. The reason for that is because this is not a degree question. They gave me these values in pi. So that means I have to do this question in pi. Okay, so I do remember the graph of y equals tan theta, and at pi by 2, which is 90 degrees, I had an infinity sort of like this. So I had this dash over there, this dash over here, and then basically what was happening was one of the graphs, one of the line curves went up like this, and then the other curve went down like this. And I don't have to draw anything more than pi, because that's not necessary for this question. And then basically the other graph is going to be y equals 1. So I could say 1 could be somewhere over here, and 1 would basically be going through this thing sort of like this. So I can see only one intersection point right there. And see, if you expanded the graph all the way to 2 pi, I'm just going to do that. This is 3 pi by 2 and 2 pi. If you expanded the graph, then you would have got something like this. Something like this. And then this line, you can see 2 intersection points. But see, we don't, this is this, right, this pi, we need everything before this pi. Everything outside of this pi is irrelevant, because that's not, see, the values they gave us go from 0 to pi. So you don't need that second intersection point. Of course, it is going to intersect at that point, but that's just not relevant to us. So we only have one intersection point to deal with. So how do we sort of deal with this intersection point? I was not supposed to erase that line. How do we sort of deal with this intersection point? Okay, so this part is what we're supposed to find, this angle right over here. So what we can do is we can basically say tan x is equal to 1, or tan theta is equal to 1, whatever you want to call it. In this case, they call it x, so we can call it x as well. Then the tan to the other side, that's going to be tan inverse of 1. And this is actually one of those values that's in the table. So if you go back to the table, you can see that when tan is 1, when tan theta is 1, the angle you get is basically 45 degrees, or pi by 4. In this case, since we're doing radians, we're going to call it pi by 4. So pi by 4. Why isn't this going down? Okay, pi by 4. So x is going to be pi by 4. And of course, there's just one sort of angle, so it's going to be this one. It's going to be pi by 4. This thing is going to be pi by 4. And that makes sense, right? Because pi by 2 is going to be a bigger number. Pi by 2 is going to be a bigger number than pi by 4, so pi by 4 has to come before pi by 2. So and that's where this point lies. It lies before pi by 2, so it's going to be pi by 4. But if you divide 1 by 2 and you divide 1 by 4, what's the smaller number? Obviously 1 by 4. So what's happening over here, pi by 2 is the greater number, pi by 4 is the smaller number. So we got our answer, and that's what we needed. So this is going to be the value for x. Now we go to question D. I'm just going to erase this real quick. And question D says that we have an equation 2 9x plus 1 equals 0. How do we solve this? How do we find the values of x for this? So what you can do is, again, you can sort of rearrange this equation. So this will basically become sine x. You send the minus to the other side, this 1 to the other side, you're going to get minus 1. And you can send this 2 to the other side, so you're going to get sine x equals minus 1 over 2. So now you basically have to solve this thing. You have to solve sine x equals minus 1 over 2. And then you can basically plot out the graph of sine x. And what are the values that are allowed? So the values that are allowed are from 0 to 3 pi by 2. So 3 pi by 2 is going to be 270 degrees. So we have pi by 2 over here. Then we have pi. Then we have 3 pi by 2. 3 pi by 2. And we have 2 pi, but that's not relevant in this case. And then we have 1 over here. We have negative 1 over here. And we can draw out our sine graph. So the sine graph looks something like this. And we don't need to draw that next part. We don't need to draw it until 2 pi. We only need we only have the values up until 3 by 2 pi. Okay. And then sine x is equal to this other graph, which is negative 1 by 2. So negative 1 by 2 is negative 0.5. Negative 0.5 maybe somewhere over here. Going to go straight like this. And it's going to intersect at this point. And of course, it's going to go forward as well, but that's not necessary. So we need sort of this point over here. Now, how do you find out this point? Now, one thing that it's actually, this is a really good piece of advice. Whenever you have a negative graph, like in this case, this is a negative 0.5. What I would recommend you to do is find out the positive counterpart of this. So if this is negative 0.5, what I would recommend you to do is find the positive 0.5 angle and then use the symmetry properties to find out whatever this angle is going to be. And if that doesn't make sense right now, I'll just solve this for you guys. You can see how to do this. So if you try and solve this directly, then this is basically going to be sine x equals negative 1 by 2. If you put this in your calculator, sine inverse of negative 1 by 2, then you're going to get a really weird angle. So if you put this in your calculator, put negative 0.5, you're going to get negative 30, or you're going to get negative pi by 6 if your calculator is in radian mode. You're going to get x equals negative pi by 3. But you can see all of these angles, these are these are positive angles, right? If you're talking about negative pi by 3, that's going to be on this side, on the negative axis. We don't have a negative axis. We are only allowed values from 0 to 3 by 2 pi. So how do we why is the calculator giving a negative angle? We don't have a negative angle. Why is it giving a negative theta? So that's a problem. So what we're going to do is you're never going to, so sine inverse of a negative number, you never do this. So you never do this. Never do this. Instead, you basically solve the sine inverse for its positive counterpart, and then you use the symmetry properties of these trigonometric functions to basically find out whatever the answer of the proper answer, the real answer of this thing would have been. Okay, so that's what we're going to do. I'll show you guys how to do this. But you never directly solve a negative value like this. You never take the inverse, the sine or cosine or tan inverse of a negative number. You don't do that. It's going to give you a negative angle, and if that negative angle is, not in your possible values of theta, you're just going to end up with the wrong answer. So you don't want to do this. Instead, the way I would approach this question is I would draw the positive counterpart of this, and I would find the angle over here. So look at it like this. Look at it like this. So this is a sine graph, right? Now if I have, let's say I have 0.5 over here, and I have the same line. I have the same line, but just in a negative version. So I have the same line over here, just the negative version. 0.5 and 0.5 are the same thing. The negative just means it's a negative version. It's a different version, but they're the same line, right? What I would do is I would find out this part. So these two things, and then these two things. So you could basically find out either this part or this part, and then this part would basically be the same as whatever the blue part was. That makes sense? Because they're the same line, right? 0.5 and negative 0.5 are the same line. So whatever this blue gap is going to be, that's what this red gap is going to be. And let's say if this was a different line, let's say this was negative 0.3, right? Then of course this wouldn't have worked. Then this would have been over here. Then this would not have been the same. Then you would need a line of positive 0.3 to figure out the angles. Okay, so the way we do this is we're going to find out the positive counterpart, and then we're going to use the positive counterpart to find out the negative, this angle over here. So the positive counterpart is going to give us these two things, and you can find out you can find out this, or you can find out this. Point is that first of all, both of these, so this is going to be equal to this, the blue part is going to be equal to the blue part, and they're both going to be equal to the purple part or the pink part. So it doesn't matter which one you find. So what I'm going to do is I'm going to find out the blue part. I'm going to, and this angle was pi over here, this was pi. So what I put in my calculator is I basically say sine x is equal to 0.5. Now I'm using the positive counterpart, remember? And so I take the inverse of this, take the sine inverse 0.5. And what I get is I basically get pi by 6. What I do with this now is I realize that, oh, this blue part is going to be pi by 6. Also, is this blue part going to be pi by 6, or is this blue part going to be pi by 6? So look at it this way. This is pi, right? This is pi by 2, and then this is pi by 6. So this pi is the biggest number because it's not being divided by anything. Then this is pi by 2, it's being divided into a half. Then this is pi by 6, it's being divided into 6 pieces. So this is the smallest part. So this can't be pi by 6 because it's right before pi. Okay, that's not going to happen. Before pi, you're going to get pi by 2 first, and then you're going to get pi by 6. So that means this angle has to be pi by 6. Okay, so this angle, this space that you just figured out, this space is equal to pi by 6. This space is equal to pi by 6. So basically, this angle that you move to the right, this angle is going to be, let's zoom in over here, this angle is going to be pi by 6. Now, if you want to find out this angle, what you would have to do is you would have to go in this direction by pi by 6. So you take this pi and you subtract from it pi by 6. You subtract from it pi by 6, and you're going to get the angle at this position. But that's not what I'm trying to do. What I'm trying to do is I saw that this gap was pi by 6, this gap was pi by 6, and therefore this gap is also going to be pi by 6. So what I'm going to do now is I'm basically going, I already know my angle over here. This angle is pi. I need to find out this angle right over here. What I have to do is I have to go to the right by pi by 6. What I'm going to do is I'm going to take my pi, I'm going to add my pi by 6 into it, and I'm going to get some new value. Let me just find that value out. So pi plus pi by 6, that's going to be 7 pi by 6. Now that is going to be my answer for this. So my x is going to be, this is incorrect. This is not correct. This is going to be 7 pi by 6. Okay, that's how you do a question where you have something going in the negative part. You basically change it into a positive counterpart. You solve for the positive counterpart, and then you basically think about what the negative counterpart is going to be using the symmetry properties of these sine, cosine, and tans. Now, part E says we have 4 sine squared x plus 2 equals 3, and we're allowed the values of x to be from 0 to 2 pi. So this is going to look something like, if I solve it out, it's going to look something like 4 sine 2x plus 2 equals 3. Now, what we do is we make sine x the subject first, because that's what we did in all of the previous problems. So we are going to make sine x the subject. It's going to be 4 sine squared x. Take this 2 to the other side, you're going to get 1. And then take this 4 to the other side, so we're going to get sine squared x equals 1 by 4, and send the square to the other side, so we're going to get sine x. Now see, sine x has become the subject. You're going to get under root plus minus under root of 1 by 4. You're going to get two equations. Sine x is equal to positive 1 by 2, and sine x equals negative 1 by 2. So again, we can sort of draw out our sine curve. So this is going to be the x, this is going to be the y, this is a graph of y equals sine theta or sine x, whatever you want to call it. And then we're going from 0 all the way to 2 pi. So you got 0, you got pi by 2, which is 90. Then you got pi, which is 180. Then you got 3 pi by 2, which is 270. And then you got 2 pi, which is 360. And then sine goes from 1 all the way to negative 1. 1 to negative 1, and then the graph looks something like this, like this, like this, and like this. Okay, and now we have, so we have to solve it for positive 1 by 2 and for negative 1 by 2. So I'm not going to draw out two different graphs, because this is sine, so the sine graph is the same. But I can just draw out these two lines. So 1 by 2, I have to solve it for 1 by 2 and negative 1 by 2. So 1 by 2 basically means 0.5. So I'll have a positive 0.5 going like so. I'll have a, so this is a positive 0.5, and I'll have a negative 0.5 going like so. So this is negative 0.5. And you can see they're actually already counterparts of each other, right? These things are counterparts of each other. Positive 5 and negative 0.5 are the counterparts of each other. So if you can find the positive values, you can use them to find the negative values, because you don't find the negative values on their own. You're going to use the positive counterpart to find out the negative values. That's what I'm going to do. So you're going to get two intersection points over here, this guy and this guy. And then you're going to get two intersection points over here, this guy and this guy. And see, this much angle is going to be equal to this much angle, and then this gap is going to be equal to this gap. So all of these gaps are equal. The reason is because these lines are 0.5. This is also 0.5. The only difference is it's a negative 0.5, but it's 0.5 still. So all of these angles are equal to one another. So if you can just find one of them, you will be able to find all of them. And I'll show you guys how to do that. So the first thing we do is, obviously, you're not going to use this. Again, you're not going to use this because you do not sine inverse a negative value that gives you messed up answers. So we can go with this and we can say x is equal to sine inverse of 1 by 2, and you're going to get pi by 6. And this is actually in your table as well. If you see, you have sine theta being equal to 1 by 2. If you inverse this, you're going to get pi by 6 or 30 degrees. This is in your table as well. So pi by 6, that means this part is going to be pi by 6. Now, how do I know this is pi by 6? Well, because see, if this is pi by 2, right? Pi by 2, then pi by 6 is less than pi by 2. So it has to come before this guy. That's why the first angle is pi by 6. Okay. Now if so that means I went to the right by pi by 6. I went to the right by pi by 6. So then what's this angle going to be? What's this angle going to be? What's this angle going to be? And I can find those angles out. So basically this angle basically means I'm going to the left by pi by 6. And then this angle, this guy was pi, right? So if I subtract pi by 6 from pi, then I'll basically know what that second angle is going to be. So pi minus pi by 6 is going to give me 5 pi by 6. So this is going to be 5 pi by 6. So these are the blue values. The blue values are pi by 6 and 5 pi by 6. And then the green values that I'm going to get are going to be so this part is to the right of pi. So I just say pi plus pi by 6. And I believe we did this in the last part, and this was equal to 7 pi by 6. So that's going to be one value, 7 pi by 6. And then this angle is to the left of 2 pi. Right? This thing is 2 pi. Now I have to go to the left of 2 pi. So that means 2 pi minus pi by 6 is going to be, let's solve that out. So 2 pi, what am I doing? 2 pi minus pi by 6. That's going to be 11 pi by 6. 11 pi by 6. So that's going to be 11 pi by 6. Those are going to be all of the answers for this question. Okay, so heading on to part F. And part F says, I'm going to delete this. Part F says that we have sine x equals 0.5, and this time we have to go from negative 360 all the way to 90 degrees. Okay, this is the first time we're going to involve a negative angle. So I'm going to draw out my sine graph. So this is going to be my sine graph. We're doing this one, yes. So sine graph y equals sine x. So we have to go all the way to 90 degrees. And then we have to go all the way to 360 degrees in the negative side. So if this is 0, then this is going to be negative 90, and then negative 90 degrees, and then negative 180 degrees, and then negative 270 degrees, and then negative 360 degrees. Okay. And on the positive side, we only have to go all the way up till positive 90 degrees. So let's just draw this over here, positive 90 degrees. And then sine goes from 1 to negative 1. 1 to negative 1. Okay, so we have sine of x, it's equal to 0.5. So let's draw the graph of sine of x. So this is what a normal sine graph looks like, and up until 90 degrees, it's this is 90 degrees, and this is 180, then this is 270, then this is 360. So we just have to draw this part out. This part is going to look something like this. You could draw more if you wanted to, but that's not necessary because you're only asked to go up until 90 degrees. And then how do we draw the negative part of this? So this is what a sine graph looks like, right? Now imagine if, see this, if I just draw out the remaining part, this is what it's going to look like. So if you're to draw a graph on the negative side, how is it going to look like? Or actually, you know what? I'm not even going to draw these sides for now. I'm just going to draw a rough sketch to make it simpler. If you draw out an angle, a sine to the negative side, what is it going to look like? Is it going to look like this? This isn't a sine, right? You just drew this. This is not a sine curve. A sine curve looks like this. So the way you can draw this is you can basically sort of imagine that you pick up this curve and you pick this curve and you put it over here. And that is what the sine looks like. So it just keeps on repeating, right? If you draw over here, it's going to look like this. The sine just keeps on going and going and going. So if you are to draw the negative side, you are to draw the negative side of a sine graph, then you can imagine this is what a sine looks like. If I just pick it up and I put it over here, what is it going to look like? So it's going to look something like that. Okay, and then this is obviously going to be negative. Wait, I have to sort of increase the height over here. It has to go to -1, and then it has to go. Going to be all the way to -1, and then it's going to go all the way to +1, and then it's going to come down like this. Okay, so this is going to be -90 degrees. This is -180 degrees. This is -270 degrees. This is -360 degrees. Okay, now these are the possible values of x that I can have. Now I have to draw the line y equals 0.5. So 0.5 can be somewhere over here. So the line is going to look something like so. And it's going to intersect this point, this point, this point. And of course, the line is going to go forward. It is going to intersect that point. But that's not within our range. Our range is between this and this. So we don't have to be concerned about what's outside of our range. We can even erase this part. This is of no concern to us. So we're trying to find out what this angle is, what this angle is, what this angle is. And again, we're going to use symmetries over here. So this thing looks the same as that thing. And this thing also looks the same as the other two things. So if you can just find out one of these, this gap, you can find one of this gap, then you can find all of the angles. And I'll show you guys how to do that. So what you do is you basically, the first angle you can find by just saying sine of x equals 0.5, and then you take the inverse, sine inverse of 0.5. And sine inverse of 0.5 is going to give you, if you're doing this in radian modes, going to give you pi by 6. Pi by 6. Okay, so that means, first of all, what angle is going to be pi by 6? Which of these angles is going to be pi by 6? So it can't be the negative angle, of course, right? Can it? Because this pi by 6 doesn't have a negative sign. It has a positive sign. So it only makes, oh, actually, we have to do this in degrees. This was a degree question. This is going to be 30 degrees. So 30 degrees isn't a negative number, so it's not going to be on the negative side. It's going to be on the positive side. And it's less than 90, so it has to be on the left side of 90. So it just makes sense that, oh, there's only one intersection point that's on the left side of 90 degrees and is also positive, and that is this intersection point. So that means this angle is going to be 30 degrees. So that means I went to this side by 30 degrees. I'll go to this side by 30 degrees, and then I'll go to this side by 30 degrees. So one of the angles is 30. Now what's going to be the second angle? So see, this right here is negative 180 degrees, and you're going to the left of 180 degrees by 30. So you're going to the left of 180 degrees by 30. So what you can do, you can say negative 180 minus 30, and that's going to be Negative 180 minus 30 is going to be negative 210. That's one of the angle, negative 210. And then the other angle, see, this is negative 360. This angle is negative 360 right over here. And you're going to the right by 30 degrees. So you can say this is going to be negative 360 degrees plus 30 degrees. This is going to be negative 330 degrees. That's another angle. And you can see you had 3 intersection points and you found out this was a negative. You found out all the 3 angles over here. And then 2 of them were negative, so 2 of your angles are negative. One of them was positive, so one of your angle is positive as well. Okay. Now we are going to go over to part. So delete this. We are going to go over to part G. Part G says cosine x plus 1 by 2 is equal to 0. And we're allowed to go from 0 all the way to 360. So cosine x equals 1 by, sorry, cosine x plus 1 by 2 equals 0. So we can make cosine x the subject. So this is going to be cosine x equals negative 1 by 2. And then we can now sort of plot out our graph of cosine x from 0 degrees to 360 degrees. This is 0. We're going to have 90, 90, 180, 270, 360. I'm going to do that in just a second first. What I'm going to do is I'm just going to draw out this cosine graph. And so this is going to be 360. This is going to be 270. This is going to be 180. This is going to be 90. And then this is 1. And then this is negative 1. Okay. 1 by negative 1 by 2, that is going to be over here. Y is equal to negative 1 by 2. Negative 1 by 2 means negative 0.5. It's going to be over here. So these are 2 intersection points that I'm going to get. This guy and this guy. Now, what did I say about having negative curves or negative lines? Now, you don't make the mistake of solving this as it is and doing this. You do not do this. Put a big cross on this. You don't do that. Instead, you go for the positive counterpart. So instead, you would maybe try out a line which is going to be positive 0.5. And so that line is going to do something like this. Going to intersect over here, intersect over here. So you're trying to find out whatever this gap is or whatever that gap is. And it's going to be the same gap as this gap and as this gap. Those are just, symmetric properties. So we can go ahead, we can say, okay, what is cosine x equals 1? So we're taking the positive counterpart now, and we're going to apply the inverse on this positive counterpart. It's going to be positive 1 by 2. So you're going to get cosine inverse of 1 by 2 is going to give you 60 degrees. This is, again, given in your table. A lot of these values are given in your table. So cosine 1 by 2 gives you 60 degrees. Okay, so now that we have 60 degrees, that basically means that, which of these is going to be 60 degrees? Look, if this thing was 90 degrees, then it makes sense that 60 is going to be less than that. So this is the intersection point that is less than 90, so this intersection point has to be 60 degrees. So that means you went over here by 60 degrees. But that's not what you're concerned about. You're trying to find this gap right over here, because that gap is then going to be this gap as well as this gap. So how do we find that gap? We just say 90 minus 60 is equal to 30 degrees. And so this gap is now 30 degrees, and this gap is 30 degrees, and this gap is also 30 degrees. So how do we find out this second intersection point? How do we find out this intersection point? Well, you can see this angle was 90 degrees, and you went to the right by 30 degrees. So what's going to be your angle? So 90 plus 30 is going to be I believe, 120. So one of your angles is going to be 120. This angle is 120 degrees. And then what is this intersection point going to be? So see, this is 270, right? 270, and you're going to the left by 30 degrees. So when you do that, you're going to subtract 30 degrees from 270 degrees, and you're going to end up at 240 degrees. So that's another one of your angles. So we found out that x was basically equal to 120 degrees, and it was equal to 240 degrees. That's done. Okay, now we are going to do part H. And part H is where things start to get a little bit complicated. So part H says we have cosine squared x, and we have sine x, and this is equal to 1 by 2 sine x, and these are the possible values of x that are, or the possible values of theta that are allowed. So how do we sort of solve this question? This has, not only does it have cosines, but it also has sines. So the first thing you want to do is you want to get rid of whatever trigonometric function you can get rid of, because you cannot solve two trigonometric functions at once, right? All of these other questions that we did, what we did was we basically got one trig function, like let's say sine, and we got some value for it. So that's what we're trying to do. And one thing I can see right off the bat is I can get rid of the sine functions. So if you send this sine to the other side, what's going to happen is you're going to get is equal to 1 by 2 sine x over sine x, then these sine x cancel out. But you have to make sure of one thing before you can do this step. And that is that, you see, this sine x can have a range of values. That depends on whatever this value of x was given to you. So what the value of x that was given to you was between 0 to 90 degrees. From 0 to 90 degrees. And therefore sine x can be between whatever the sine x is going to be. So sine x is what? So if you put 0 in here, if you put 0 in here, so this is sine x, right? Sine x. If you put 0 in here, you are going to get sine 0 is what? Sine 0 is 0. And then what is sine 90? So sine 90 is 1. So the values of sine x can be between 0 to 1. If I go up over here, let me just check if sine 0, I'm not remembering this correctly. Okay, sine 0 is 0 and sine 90 is 1. So basically, sine x can be anything between 0 and 1. But it cannot be 0 and 1. It can be anything between those. And the reason for that is because if you look at this guy, this allowed values of x to be greater than 0 and smaller than 90 degrees. So sine x can be greater than 0 and smaller than 1, anything between these two values. It cannot be 0 and it cannot be 1, because this is not equal to, this is just greater than and smaller than. They don't have an equal to sign. But what if they did have an equal to sign? Now you cannot cancel out those two sine x's. The reason for that is because then your sine x can also be 0. And so if you say sine x over sine x, and let's say they can be equal to 0, then what you're also saying is you're saying that 0 is basically over 0. And then you cannot cancel this out. This doesn't give you a valid answer. If you try to divide 0 by 0, you know what you get. You don't get an answer. That's a math error. That's undefined. So you can't do this. So over here, the entire reason I was able to cancel out the sine x with the sine x is because it could not be equal to 0. It could be anything that's greater than 0, but it could not be 0. So you have to check when you're doing this. You have to check if sine x can be 0 or if it cannot be 0. If it can be 0, then you can't do anything about it. You can't cancel it. In this case, we were able to sort of cancel it because it's not equal to 0. Okay, so we canceled out the sine x with the sine x, so we're just going to be left with 1, because anything divided by itself is 1. This is going to be cosine squared x equal 1 by 2, and then we can underroot it. So this is going to be cosine x equals plus minus under root 1 by 2. And you can then expand this. You can say cosine x equals under root 1 under root 2, and then obviously the plus minus. So under root 1 is just going to be 1. You're going to get cosine x equals positive 1 by under root 2, and cosine x negative 1 by under root 2. Those are the two values that you're going to get. Okay, so we have to solve this. We have to solve these two equations now, and we have to find the possible values of x. So what I'm going to do is I'm going to plot out my cosine graph. This is what my cosine graph is. This is going to be my x. This is going to be my y. Y equals cosine x. And what are the possible values of the angles that I can get? So those are from 0 degrees all the way to 90 degrees. This is 0, and then this is going to be 90 over here, and I don't have to plot anything else. So if this is what a cosine graph is, then you're only allowed to draw it up until 90. So this is basically going to be 0 degrees. This is going to be 90. This is going to be 180, 270, and then 2 pi. So I'm only allowed to draw until over here. After that, nothing is of my concern. So this is going to look something like this. And this is obviously going to be 1. This is going to be negative 1. Okay, so good thing is this equation is not going to give you any answers. So you can say no answers. No answers. And the reason for that is because if this is negative 1 by under root 2, so it's a negative number. It can be somewhere over here, somewhere over here. That doesn't matter. That's not the point. Point is that this line, let's say it's over here, it's going straight. There is no cosine graph that it can intersect with, because we're only allowed from 0 to 90 degrees, and from 0 to 90 degrees, the cosine graph is only in the positive part. It's not in this negative part. So no matter wherever this line is, because this line is negative, it's never going to intersect with the cosine graph. Now, of course, if we were allowed more values, like values greater than 90 degrees, then the cosine graph would be doing something like this, and then we would have intersection points. But right now, we don't have any intersection points, so we can just say we have no answers from this part. Okay, what about this other part? So 1 by under root 2. First of all, let me just check what 1 by under root 2 is equal to. So it's equal to 0.707. So that's going to be somewhere over here, 0.707. This is positive 1 by under root 2. It's going to be going like this. So we can see one intersection point over here. So what we can do is we can say x is equal to cosine inverse 1 by under root 2. And this is going to be, we can take cosine inverse of 1 by under root 2, and we actually have this value in our table as well. So cosine, we have this is 1 by under root 2. When you inverse this, you get 45 degrees or pi by 4. We are looking for 45 degrees or pi by 4. 45 degrees or pi by 4. So we're dealing with this graph in degrees. This is going to be 45 degrees. And it makes sense, right? Because 45 degrees is less than 90 degrees. So it makes sense that this thing is going to be 45. So this angle is of 45 degrees. So we can just say x is equal to 45 degrees. That's the only one answer we're going to get, and that's done. Okay, so moving on to part I. Part I says we have 3 sine 2x plus 1 equals 0, and then we're given some range for x. Now, this question is a little tricky, and the reason for that is because instead of having x or instead of having theta, we now have 2x. So how do we do such questions? Before I do this, I'm just going to check if my laptop still has battery. Okay, so we're still going good. Okay, so I think we will be able to complete this in time. Okay, how do we solve this? Because if you go and look at the previous questions, this was x, this was x, this was x, this was x, 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 theta, theta. Now we have 2x. So how do we deal with this? So one thing you can do right off the bat is I'll tell you guys how you deal with questions like this. But first of all, let's make sine the subject, right? So right now we have 3 sine 2x plus 1, 3 sine 2x plus 1 equals 0. So you make sine the subject. This is going to be sine 2x equals minus 1 over 3. Okay. Now, see, they've given this is 2x, and they've given you the range, which is negative pi greater than x and smaller than pi. Okay, this is the range. These are the possible values for x. Now, you don't wanna solve for x, do you? What do you have? You have 2x. So what you're going to do is you're going to convert this range into 2x, because you can solve this range is not what you have. So you have to make these two the same. So the way you do that is you basically take this thing and you can multiply this entire thing by 2. And if you do that, you'll realize now if you multiply this with 2, it does turn into 2x. That's what you have. But then you have to multiply this with 2, and you also have to multiply this with 2. So this is going to be negative 2 pi, and that is going to be 2 pi. Now you have 2x there, and you have, oops, you have, wait, you have, what have I done? Hold on. Okay, so you have 2x there. Wait, my pen just stopped working for no reason. Okay, so this is 2x, this is 2x, and that is 2x. So they're now the same. Now, the other thing you do is you basically give this a name. So you can call it theta. And so you give this a name and you can call it theta. So again, what do you do when you have, let's say you have sine, let's say 4x minus 1 in here. And let's say you have the range x is greater than negative 1, and x is smaller than, sorry, x is greater than negative pi, and x is smaller than pi. What do you do when you have a situation like this? So you can see that this range is not the angle you have. You have 4x minus 1. So what you're going to do is you're going to try to make this thing the same as what you have. So you're going to multiply this with 4, and you're going to subtract 1 from it. So all of this is going to look like 4 pi minus 1. And this is going to be 4x minus 1. And this is going to be 4 pi minus 1. That's what you're going to do. Now, the second step is to give this thing a name. So you can call this theta, and you can call this theta as well. Or you can call it anything else. You can call it, like, let's say alpha. You can call this alpha. Anything you like, doesn't matter. Important thing is, step 1, whenever you don't have, whenever you're not just dealing with sine x and you're dealing with something else, first thing you do is you check the range, see if the range that you have is similar to what's inside your sine or inside your cosine or inside your tangent. Second thing you do is you give whatever you have, once you make these two things similar, you give them a name. Okay, and that's going to be really useful. So once we've done this, we've done these two steps, now we can actually go on to attempting a question like this. Okay, so now we have sine theta equals negative 1 by 3. And now you basically have the range for theta as well, right? You have a range for theta, which is going to be theta is less than 2 pi, but is greater than negative 2 pi. Also, what is theta? Theta is basically 2x, right? You give it a name, and we gave it the name as theta. So we gave 2x a name, and that name is theta. So now this is what we have, and this looks way similar to what we've solved in the previous questions. So what we did was we took a hard question and we made it, we did some steps to make it similar to what we were doing before. And so now it's really easy. All you have to do is you have to plot out that sine graph. We have to plot out y equals sine theta. That's going to be theta over here, y over here. So sine theta looks something like this. And then this angle, oops, this angle. Oh, actually, we do have a negative part, so we do have to take into account the negative part as well. Okay, so we need a negative part as well. So this could be our y, and then this could be our negative part. So a sine graph would look like this, and a sine graph would also look like. So if you don't know how to draw the negative part, you can sort of imagine it in your head that a sine wave looks like this. So I'm supposed to pick it up and I could put it over here, and that does the trick. But if you don't have a problem with that, you can just sort of draw out the sine graph. Oops, I'll have to draw this again. You can draw it again like this. Okay, so this is 0. This is going to be 90. This is going, wait, we're not 90, we're supposed to do this in radians. So 90 is pi by 2. This is going to be pi by 2. This is going to be pi. This is going to be 3 pi by 2. This is going to be 2 pi. And then over here, we're going to go in the negative pattern. So this is going to be negative pi by 2, negative pi, negative 3 pi by 2, and negative 2 pi. Okay, so we have positive values for theta, and we have negative values for theta. And now what we have to do is we have to put this equal to this line, which is negative 1 by 3. So negative 1 by 3 is going to be 0.-33333. It's going to be somewhere over here. Somewhere over here. I'm going to do something like this. So this is almost equal to negative 0.33333. Okay. What do we have to do? We cannot solve negative numbers as they are. We don't just take sine inverse of a negative number. Instead, what we do is we try and solve its positive counterpart first. You can see this would yield 4 solutions, 2 over here, 2 over here. And since they are all sort of symmetric, what you can see is that this part would be the same as this part, and then this gap or this part would be the same. So all of these gaps would be the same. That's the special part about these trigonometric functions, and sort of their speciality, you can call it. But we are not going to solve out the negative part. We're going to convert this into the positive part. So we're going to convert this into positive 1 by 3. So positive 1 by 3 would be 0.333, and it would be somewhere around here as such. So this is the positive counterpart, these two intersection points and these two intersection points. And all of these are symmetric. So this thing, this gap, this gap, this gap, and then the green gaps, all of these gaps are symmetric. That's really important. So if you can find out one of these gaps, you can sort of go ahead and find out all of these gaps. So that's what I'm going to do. So remember, right now we're not going to be solving for the negative counterpart. We're going to be solving for the positive counterpart. So if we say sine theta is equal to positive 1 by 3, and then we find the value of theta by taking sine inverse 1 by 3, we're basically going to get sine inverse of 1 by 3. And you're supposed to do this in radians, right? Because this question was given to you in radians. You turn your calculator into radian mode, and you take the inverse of 1 by 3. So you get 0.3398 radians. Okay. So what we just solved this for the blue part. What angle did we get? Did we get this angle, this intersection point? Did we get this intersection point, this intersection point, or this intersection point? That's the first question. Which intersection point did we get? So it's, first of all, see this radians, this answer that you got. Is it a negative answer or is it a positive answer? So it's not a negative answer, right? So that means you can't have this angle or this angle because these are in the negative regions. your theta is not negative. You got a positive value for theta. Okay, now so that leaves this angle and this angle. So which angle is it going to be? Is it going to be the angle that is the further away, or the angle that is closer to 0? It's really easy to answer that, because see, this is pi by 2. This thing is pi. So pi is basically equal to 3.142. Pi by 2 is going to be the half of that. So if this is 3.142, this is going to be 1.5 something something something, right? The half of 3 is 1.5, and then the half of 1.42 is going to be something something. And your angle theta is 0.3398. So is it going to be before pi by 2, or is it going to be before pi? So obviously it's going to be before pi by 2, right? So that means it's closer to 0. That means the angle the intersection point you just found out is this intersection point. This intersection point right over here. So this intersection point that you just found out, I'm just going to zoom in onto this. Oops, wait, my stream, something's up with my stream. Is lower than the recommended. Let me just, hold on guys, give me a second. We recommend to use, okay, I think this is okay. I don't think anything's wrong with the stream right now. Huh, okay, the connection's good again. Okay, anyways, back to what we were doing. Okay, hold on. View full page. Right. So if I zoom in on this part, what you can sort of see is that this is my sine graph. This is the angle over here. And this angle is 0.3398 radians. And this is my curve, right? So that means I went to the right by 0.3398. So what I found out is I found out this gap. This gap is equal to 0.3398. Now, once I have this gap, I can find out all of the other gaps. So remember, this is not your answer as of now. This is not your answer. This is just the gap that we found. Now, all of the stuff that I'm going to find in green, that's going to be your answer. So this thing, this thing, this thing, and this thing. So I can call this 1, I can call this 2, I can call this 3, I can call this 4. So let's start off with 1. So theta is going to be, so you can see this is negative pi, this thing is negative pi, and you are this gap to the right of negative pi. So the way you find it is, you basically, if you're going to the right, you are just going to add your 0.3398, or you're going to add the gap into your negative pi. So you're going to get some angle which is going to be negative pi plus 0.3398. So that's going to be negative 2.8 radians. Okay, that's your first angle. Your second angle is going to be, so this was 0, this thing is 0 degrees, and you're going to the left. So if you're going to the left by 0.3398, then that's just going to be negative 0.3398 radians. And then for part 3, you can sort of see that this thing is pi, and you're going to the right of pi by 0.3398 radians. So you can say pi plus 0.3398. That's going to be pi plus 0.3398. That's going to be 3.48 radians. And then for the last part, part 4, you can see that this is 2 pi, and you're going to the left of 2 pi. So you can say 2 pi minus 0.3398, and that's going to be 2 pi minus 0.3398. So that's just going to be 5.94 radians. So all these are all of the green angles that you were supposed to find. And they make sense because see, two of these things, this guy and this guy, were in the negative part. So this is a negative angle, this is a negative angle. And then this thing and sorry, this thing and this thing were in the positive part, so these two angles are positive. So that's it for your part I. Now part J, let's try and solve part J. So we're going to try and solve part J. Now part J is a quadratic equation. I don't know if you can tell or not, but this is a quadratic equation. So tan squared theta plus tan theta is equal to 0. Now you may not be able to figure it out right now, but let's say you say tan theta is equal to x. So now you can replace tan theta with x, and you can replace tan squared theta with x squared, and now it's a quadratic equation. It's in the form ax squared plus bx plus c. So c is obviously going to be 0, b is going to be 1, a is going to be 1. So you basically have a quadratic equation right now. So how do we solve this quadratic equation? So you can use the quadratic formula. You can use the quadratic formula, or you can factor it out. So if you factor it out, this is just going to be, I mean, you can do whatever you want. You can use quadratic formula, factorization, vertex form, whatever you want, whatever you use to solve a quadratic. I'm just going to factor this out. This is going to be, if I factor out an x, I'm basically going to get x plus 1 equals 0. So I'm going to get two answers from this. It's going to be x is equal to 0 and x is equal to -1. So these are the two answers that I get. Now remember, x is not what I'm trying to solve for. I'm trying to solve for tan theta. So I can replace the x with tan theta equals 0 and tan theta equals -1. And now I basically have to solve these two equations. So I can plot out a graph of tan theta, and I'm allowed values from 0 to 360 degrees. So if I draw out my curve, this is my y, this is my theta, and this is going to be a graph of y equals, my pen stopped working again. Okay, this is going to be y equals tan theta. Okay, so the graph of tan looks something like this. Then it looks something like this. And it looks something like this. And we have a line as such over here. I mean, you don't have to draw this dotted line, but it's helpful when you're sketching the curve. But it's not necessary. This dotted line, you don't have to draw it out. Okay, this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then this is 360 degrees. Right? This is the graph of tan. Okay, so I have a line which is equal to y equals 0, and I have a line y equals -1. So y equals 0 is pretty straightforward. It's just going to be this line. Y equals 0 is the line of the x-axis, or the line of the horizontal line over here. Okay, so this is the first line, and I have to find out the intersection points on this line, and this is pretty straightforward. This is not difficult at all. You can just see all of the intersection points. And so the origin, of course, would be your first intersection point. And then you can see this, the graph is passing through 180 degrees. This is an intersection point. And then the 360 is also an intersection point, but if you check out the range, see, your theta is allowed to be 0 because it can be equal to 0, but it cannot be equal to 360 degrees. So the final, this third point is not going to be an intersection point. This is not going, I'm going to put a cross on this. This is not going to be an intersection point. It's outside of the range. So theta is equal to 0 degrees, and it's also equal to 180 degrees. Okay, that was pretty straightforward. That was not difficult at all. Now, what about the second equation? So the second equation says tan theta is equal to -1. So that would be someplace over here. Let's say -1 is over here. The y equals -1. The line of y equals -1 would be something like this. Now, we know that whenever we have a negative value, we tend to first find out their positive counterpart because that's just simpler. So we can take y equals +1 and the line would look something like this. So we're trying to solve for this line, okay? And so we will have two intersection points over here, this intersection point, and we will have this intersection point over here. Okay, so they will correspond to this intersection point, and they will also correspond to this intersection point. Now, tangent is a bit tricky. Tangent is not as simple as the rest of the problems. Tangent is a little bit tricky because it's not just straightforward symmetric like that. If I draw this out a little better, I think I may be able to do a better job. So this is going to be like that, and then the intersection point, and then it's going to go up like this, and then it's going to go down like this, 360 degrees. So that's the point over there, and it's the point over there. Okay, so this is going over here, this is going over here. Okay, now what are we going to look at? So you can see this gap, this blue gap, is going to be equal to this gap. How did I figure that out? Well, if you see this thing is, this is the vertical part, right? And then for this bottom part, this right here is the vertical part. So if you're looking at this blue part, which goes from the intersection point to the vertical part, then over here, that's what you're going to do. This is the intersection point, and you're going to go to the vertical part, right? Because you don't want to say this thing is equal to this thing. That would be wrong. This doesn't include the vertical part. This is when you're going, when it's over here at the bottom, and it's curving to the intersection point. So this part would actually be equal to this part from the intersection point, where it was sort of low like this, and it went all the way to the intersection point. So these graphs are symmetric, but you have to choose the right points. You have to choose the right gaps. You can't just sort of say whatever gap is equal to whatever gap. It has to match, and this matches. So this is the intersection point, and you're going all the way to the vertical part. And then this is the intersection point, and you're going all the way to the vertical part. So this gap must be equal to this gap. Okay, so what we are going to have is this gap, and it's equal to this gap. Okay, now I think we can solve this. And then also this gap will also be equal to this gap over here and this gap over here. So the gaps, you have to sort of check out the symmetry for the gaps. You cannot, not every gap is equal to every gap. The gaps have to match. And in sine and cosine graphs, that's a bit easy to do. In tan graphs, you have to be a little bit careful about this. Okay, so all of these blue gaps are equal to each other. So what I'm going to do is, if I can find even one single one of these gaps, I can find all of the other gaps. So I'm going, since I took the positive counterpart, I'm going to say tan theta is equal to +1. Take tan inverse of +1, and you are going to get 45 degrees. This is equal to 45 degrees. So that means, so which gap, which of these angles is going to be 45? Is it going to be this one, this one, or so actually it can't be the bottom part because I took the positive value, I took the positive counterpart. So is it going to be this first angle or is it going to be the second angle? And it's going to be the first angle because see, if this is 90 degrees, if this line represents 90 degrees, then 45 degrees has to be behind this 90 degrees. So that means this angle right here is 45 degrees. But I'm not trying to find that angle. I'm trying to find this gap. And this gap exists between 45 degrees and 90 degrees. So how do I find out that gap? I just subtract 45 from 90 and I get 45 degrees. So this blue gap is actually 45 degrees. That means this gap is 45 degrees as well as this gap is 45 degrees. And now what I have is essentially, if I erase all of this stuff, I erase all of this line because I don't need that anymore. I basically have this. Yes, I have this. Okay, so now I know what this gap is between the intersection point and this line, and then between this intersection point and this line. So these are 45-degree gaps, 45 degrees, 45 degrees. So if I'm trying to find the first intersection point, what I will do is see this line is 90 degrees, and I'm going to the right because the intersection point is to the right of this. I'm going to the right by 45 degrees. So you're just going to do 90 plus 45, and that's going to give you the first angle. So 90 plus 45 is going to be, I think that's 135. 90 plus 45, that's 135. And then over here, this thing is 270, and you're going to the right. So this is the intersection point. You're going to the right by 45. So 270 plus 45 is going to give you 315. The other angle is going to be 315. So the two answers you get from this are theta is equal to 315 and 135 degrees. And remember, this angle you found out, this was not the answer. This was just that gap that you found out. This is not the angle. This we did the positive counterpart just to find out what the gap was equal to. These are the angles. These guys are the angles. So this is basically going to be your answer. And this took a little bit of time. The last part took a little bit of time, but that's just because I'm explaining it to you guys, and you guys are probably doing this for the first time. The more you practice this, the easier it's going to get, and the easier you're going to be able to see the symmetries, and the easier you're going to be able to do these questions. So that's a really important thing. Practice these as much as you can. Okay, now moving on to the last part of trigonometry for Pure 1, that's going to be your trigonometric identities. And these are the two identities that you need to know. So cosine squared theta is equal to sine squared theta. And cosine squared plus sine squared theta is equal to 1. And then sine theta divided by cosine theta is equal to tan theta. Now these two identities, you can rearrange them. So maybe you can change this into cosine squared theta is equal to 1 minus sine squared theta. Or if you make sine squared the subject, then you're going to have sine squared theta is equal to 1 minus cosine squared theta. So those changes, you need to know that's also a possibility that you can do. And then over here, you can also change this guy. You could say sine theta is equal to cosine theta and theta. And of course, you need to know a few identities from your O levels, especially this one, which is a square minus b square is equal to a plus b, a minus b. I've seen this identity being used up many times. You need to know this identity as well. Okay, so how do you prove identities? So they'll give you some fractions, some form, and you will have to change it into that other form. And usually how they do this is you have the left-hand side and you want to turn it into the right-hand side. I wouldn't recommend anyone to start from the right-hand side. I would always say start from the left-hand side and try to convert it into the right-hand side. So there are some general tips from it, and the tips are, number one, get a rough idea. Get a rough idea from the question. Get a rough idea, and then just solve. to solve. And then the second thing, don't worry about planning. You do not plan trigonometric identity questions out. If you start planning, you're going to get cooked. So even as of now, I don't know how this left-hand part is going to convert into the right-hand part. That's not what I'm going to do. I'm just going to get a rough idea of what I'm supposed to do, and then I'm just going to solve. I'm going to get the answer. The answer is going to make itself obvious, okay? You don't have to worry about that. So the first thing is to get a rough idea. The rough idea is I'm supposed to get rid of all the sines and cosines because I'm going to convert this left-hand side to the right-hand side. And you can see on the right-hand side, we don't have any sines or cosines. So the first thing is get rid of sine theta and cosine theta. Turn it into tan theta. That's the first idea, right? Second idea, I only have one fraction. I don't need two fractions, I need one fraction. Now I can start solving this, and I don't know how it's going to convert into 1 over tan theta, but it's going to happen, trust me. If you don't worry about it, follow the steps, it happens automatically. And you have to practice a lot of these identity questions because that's the only way to improve at these. So we can sort of write this thing and this thing in an easy way. So we can say sine theta, or one thing we can do. So we're supposed to make one fraction, right? We're supposed to get this fraction. We're supposed to, right now we have two fractions. So one thing we can do is we can take LCM. So that's the obvious thing to do, is take LCM. And so 1 minus cosine theta is going to be multiplied with sine theta. So we're going to have sine theta over here minus 1 times 1 minus cosine theta. And then we have 1 minus cosine theta times sine theta. Now, I would never recommend you to expand out these denominators. You want to expand out the numerators? Definitely go for it. Do not expand the denominator unless it's really required to. Because at the end, they usually cancel out with a numerator or something. So this is a pro tip. Don't expand the denominators unless you really need to. So don't expand denominators unless you really have to. You really have to. Okay. So then what do? Expand the numerators. So sine theta times sine theta, that's going to be sine squared theta. And then you're going to get this minus 1 is going to multiply inside the bracket. It's going to be minus 1 and plus cosine theta. Okay. And then this is going to be over 1 minus cosine theta times sine theta. Okay, and then what we're gonna get is, see, what's the next thing to do? What's the obvious thing to do? You can apply an identity on this guy. Apply an identity on this guy. How do I know that? Well, because as I said, this identity can be converted into sine squared theta equals 1 minus cosine squared theta. Okay, so I convert this into the identity 1 minus cosine squared theta. This is going to be minus 1 plus cosine theta over 1 minus cosine theta times sine theta. And then this thing cancels out this thing. And so I'm left with minus left with cosine theta minus cosine squared theta over 1 minus cosine theta times sine theta. And see, this is why I told you not to expand the denominator, because see, what we're trying to get is 1 over tan theta, right? And if sine theta over cosine theta is tan theta, then basically what's 1 over tan theta? Basically, if you reciprocal this is going to be cosine theta over sine theta is equal to, and then the tan theta is going to get reciprocal as well. going to be 1 over tan theta. So that's what you're actually looking for, right? And you can actually find that because you have, see, what you can do is you can get that cosine theta and sine theta fraction. The way you do that is you can see is you already have a sine theta present in the denominator. All you need is that cosine theta in the numerator. And I can actually do that if I take cosine common from these two things. And what that's going to do is that's going to give me this bracket in the numerator, and I'll cancel out those two brackets. What I mean by that, I'll just do that real quick. That's going to be cosine theta, and I'm going to get 1 minus cosine theta over 1 minus cosine theta sine theta. So this thing cancels out with this thing, and then sine theta over cosine theta, that's just going to be 1 over tan theta. So that's your identity that has been proven. Now the second part, again, we're going to use the same steps. Don't freak out, get a rough idea, and then just try to solve it. So we're trying to get rid of sines over here. So get rid of sines. And we are trying to get one fraction. As you can see in the answer, we don't have a sine, but over here we start off with sines. So simple thing is just get rid of the sines. So what we can do is we can first of all take LCM to get one fraction. So it's going to be 1 plus sine x times 1 plus sine x over cosine x 1 plus sine x plus cosine x times cosine x, and this is going to be cosine x 1 plus sine x, right? So this is going to be 1 plus sine x squared. That's one way I can write this, because this is a bracket, this is the bracket. They're both being multiplied with each other, and they're the same thing. I mean, if you want, you can expand all of these things as well, but it's easier to do it this way. It's up to you how you want to do this. And then the denominator is going to be cosine x times 1 plus sine x. Do not expand the denominator unless you really have to. Remember that rule. And then this is going to be cosine squared x. Okay, so what do we do now? Well, we're supposed to get rid of the signs. Let's expand this bracket out. Let's expand this bracket out. And I can also expand this out. But first, let's expand the bracket out. So this is a plus b whole squared. This would be a squared. So a squared is going to be 1 plus b squared. That's going to be sine squared x minus 2ab. So minus 2. A is 1, B is sine x. A plus cosine 2x over cosine x 1 plus sine x. Okay, so we're trying to get rid of the signs, right? We were trying to get rid of the signs. One way we can get rid of the signs is if we open this thing up. If we open this thing up, we are basically going to get cosine squared theta equals 1 minus sine squared theta. And that sine squared theta can basically help us cancel out this sine squared theta. So if we expand the cosine out, we get 1 plus sine squared x. And I'm just going to write the numerator because I'm not doing anything with the denominator. So it's tedious work, so I'm not going to write it. This is going to be minus 2 sine x. And cosine squared x expands out to 1 minus sine squared x. So this sine squared x cancels out that thing, and then this 1 adds into this one, and it becomes 2. So the numerator is now going to be 2 minus 2 sine x. So my fraction is going to be 2 minus 2 sine x over cosine x 1 plus sine x. And then see, I was trying to convert this into 2 over cosine x. I already have a cosine x in the denominator, and I have 2's in the numerator. I don't want this thing. So one thing I can do is I can take both of these 2 out as common, and then I will get this bracket in the numerator. And what I'll do is I'll just cancel out these 2 things. So basically, if I take that 2 out as common in the numerator, I will get 1 minus uh, wait, I'm not. Did I do something wrong? I think I did something wrong in this question. Yeah, I definitely did something wrong, but I don't remember what I did wrong. Oh, this is what I did wrong. So when I expand this thing, this thing expands into a squared plus b squared plus 2ab. So this is a 2. This 2 has a positive sign. So this thing has to have a positive sign. Then I'll have a positive sign over here, and a positive sign over here, and a positive sign over here. This is going to be 2 plus sine x, and I will get cosine x, 1 plus sine x. Okay, so the sine x gets canceled out with sine x, and this 2 cosine x is what's going to remain. And you can see this is what I was trying to find out. Okay, so moving on to part 3. We have sine x tan x over 1 minus cosine x, and we're supposed to get rid of sine and tan. So get rid of them. Okay. One way I can write this fraction to make it a little bit easier for me is so I'm trying to get rid of the tan, right? The one way I could get rid of the tan x is I could just, I know tan x is equal to sine x over cosine x from the identity. So this is going to be sine x over cosine x. And then it's going to be 1 minus cosine x. So I'm going to turn this into a different form because dealing with this many fractions is a bit difficult. I'm going to change this into sine x times sine x over cosine x. And this thing is basically being divided by 1 minus cosine x. Okay? So what we can do is we can sort of solve this first part out, I guess. This will be sine squared x over cosine x divided by 1 minus cosine x. Divided by 1 minus cosine x. So what we can do is see we were trying to get rid of sine and tan. We already got rid of our sine. Sorry, we already got rid of tan. We had the tan initially. We got rid of tan by doing this. And now we have this thing, and we can get rid of sine because we know that if we use the identity, then we can get rid of sine and we can get cosines. So the sine squared x is basically going to be equal to cosine squared x 1 minus cosine squared x. So now we've got rid of that sine x as well. So we've got rid of all sines, all cosines, sorry, all sines and all tans. This is just going to be 1 minus cosine squared x over cosine x, and then divided by 1 minus cosine x. And then this division can change into multiplication. So the division changes into multiplication. So that's going to be 1 over 1 minus cosine x. And so what we can do is we can, what do we have to turn this into? So we have to turn it into 1 plus 1 over cosine x. 1 over, okay. How do we do that? Okay, so you know what? I'm not going to expand the denominator. I'm going to write the denominator as 1 minus cosine x. And then I'm going to write cosine x over here. Okay, and I have to turn this thing into 1 plus 1 over cosine x. 1 over cosine x. How can I do that? Interesting. I can, so I need of 1, and you get a 1 basically whenever a fraction if you have anything divided by anything, or let's say a divided by a or b divided by b. So anything divided by itself gives you 1. That's the first thing I need to know. Okay, so how do I solve this out? You know that identity I talked about, a squared minus b squared? I can apply that to the numerator. So the way I do that, and see, that's why I'm not expanding the denominator, because there is still one thing I can do. And until and unless I've done that, I'm not going to expand the denominator. You want to expand the denominator as a last resort. And the way I do that is basically I can write 1 as 1 squared, because they're the same thing, right? So then this is basically going to be a squared minus b squared. And then I can write this as a plus b and a minus b. This is going to be 1 plus cos x, 1 minus cos x, and I'll get 1 minus cos x and cos x over here. You can see this thing cancels out with this thing, and then I'm going to get 1 plus cos x over cos x. And okay, I can write these separately. So if I write these separately, I'm going to get 1 over cos x plus cos x over cos x. And this is going to cancel out to give me 1. And I will basically get 1 over cos x plus 1. And that's what they actually have. So they have 1 plus 1 over cos x. That's what I have. I can write this as 1 plus 1 over cos x. So trig identities, not something to worry about. Just stay calm. Don't try to plan it beforehand. Remember your identities and just get a rough idea from the start of the question, and then just keep on solving it, solving it, solving it. Eventually, you are going to get the answer. Okay, so that is it for the AS level trigonometry stuff. This is going to be the pure one, all the trigonometry you need for pure one, hopefully. And yeah, I hope this live stream helped you guys, and I will see you in the next video, I guess.